Hello, mathematicians. This is the video for Home Connections 83 and 84. Number 1, Anna started a race at 9:30. She ran for 3 hours and 47 minutes. What time did she finish? So a number line is a really good way to show time. I'll also show you how you could do an addition problem, although the addition problem for this one is pretty crazy. I think the number line is the best choice for this one. So let's draw a number line and start at 9:30. And it says that she ran for 3 hours and 47 minutes. I could jump in any way that I want, whatever chunk makes sense in my brain. So you might jump 1 hour, then 1 hour, then 1 hour. Or maybe you're able to jump 3 hours at the same time. So 9:30, 10:30, 11:30, 12:30. 12:30 would be 3 hours later. But she didn't just run for 3 hours, she ran for another 47 minutes. I think I'm going to jump 30 minutes to take me to 1 o'clock. And then another 17 minutes. So that way that's that total 47 minutes. So 1:17. And if she started in the morning, it must be 1:17 in the afternoon. Okay? Now, if you did an addition problem, again, this addition problem is pretty funky. And it's pretty funky because 60 is the most powerful number in time. But also with time, once it passes 12 o'clock, it doesn't go to 13 o'clock. Or 1300 unless you're talking military time, it goes back to 1. So this addition problem is pretty crazy, but I'll show it to you because I've been showing you 2 ways. Don't worry if you're like, say what? I hate that way. Because this one is, for the numbers that they gave us, pretty funky. Okay, so we're going to start at 9:30, and we're going to add 3 hours and 47 minutes. When you add, the problem is that 30 plus 47 is 77. But 77 minutes? No one ever says 77 minutes because that's more than 60. That is 77 minutes. That's an hour and 17 minutes. So if I were adding, and this is where it gets a little funky, and don't worry if you don't dig this at all. 77 minutes is the same as an hour and 17 minutes. So I'm going to carry an hour and call this 17 minutes. So I basically just changed the 77 minutes to an hour and 17 minutes. And then if I add 1 plus 9 plus 3, 1 plus 9 is 10, plus 3 is 13. But typically, you don't say 13 o'clock, you say 1 o'clock. So even though 1 plus 9 plus 3 is 13, we don't say 13, we say 1 o'clock. So again, the answer is 1:17, just like it's supposed to, but that addition problem was a little bit funky. Number 2, Michael and Tyler both ran a half marathon, 13.1 miles. Michael finished in 1 hour, 42 minutes, and 13 seconds. Tyler finished in 97 minutes and 49 seconds. So I could start with a number line, or I could do a subtraction problem to find out the difference. I can tell right now, though, who's the fast. Oh, actually, you know what I don't like about this one is that this is more than 60, and I wish they would have called it an hour and 37 minutes, because 97 is the same as an hour and 37 minutes. So I wish they would have said Tyler was an hour, 37 minutes, and 49 seconds. That way both numbers would be like the same and very similar and easy to compare. So an hour, 42 minutes, and 13 seconds, that's Michael. And if I subtract Tyler, 97 minutes is the same as an hour and 37 minutes and 49 seconds. So there's that subtraction problem. Number line, I could do as well. So who is faster? I can tell that Tyler is the lower number, so who is faster is Tyler. And if I did a number line, I would start at my lower number and jump up to the higher number. And remember, you only have to show one way. So if you'd rather show the number line, show the number line. If you'd rather do the subtraction problem, show the subtraction problem. If you want to do both because you're fabulous, do both. Okay, so let's start at the lower number, which is an hour, 37, 49 seconds. And I need to jump up to an hour, 42, and 13. So let's see, I'm going to jump up 37, 38, 39, 40, 41. I'm going to jump up 4 minutes, which would put me at an hour, 38, 39, 40, 41. An hour, 41 minutes, and 49 seconds. You might have jumped in a different way or jumped in a different order, and that's okay. I'm going to jump another 11 seconds to get me to 1 hour, 42 minutes. And I'm supposed to jump to 1 hour, 42 minutes, and 13 seconds. So I need to jump another 13 seconds. And that'll get me to the higher number. So again, I jumped from that lower number, or Tyler's number, up to Michael's number. And how much I jumped is the difference between the two. So that's 4 minutes and 24 seconds. So it should be 4 minutes, 24 seconds. There's my answer. And if I do the subtraction problem, I should get the exact same thing. 13 minus 49. I can't do 13 minus 49. So I'm going to take one of my minutes and break it up into, what's the most powerful number in time? So I'm going to take that 1 minute, I'm going to break it up into 60 seconds and add it to the 13 seconds that are already there. 60 seconds plus 13 seconds is 73 seconds. And when I subtract 73 minus 49, 13 minus 9 is 4, 6 minus 4 is 2. Ooh, it's looking good, right? 41 minutes minus 37 minutes. I can do that. 41 minutes minus 37 minutes is 4 minutes. And I can see that my answer is exactly the same as how I did it on the number line. 4 minutes and 24 seconds. A number line or subtraction is totally fine. Number 3, Takumi ran the first mile of his race in 450 seconds. How many minutes is this? How many seconds are in a minute? 60. So I'm basically doing 450 divided by 60. Or how many 60s are in 450? It doesn't work out perfectly. Think of your facts of 6. 6 times what gets you really close to 45? 6 times 7 gets you really close to 45 because 6 times 7 is 42. So if it were 420 divided by 60, right? If it were 420 divided by 60, the answer would be 7 minutes. Does that make sense? But it's not 420, it's 450, which is 30 seconds more, and that's a half a minute. So the answer is going to be 7.5 minutes. 7 minutes and a half a minute. Yeah, that's fine. Okay? So 7 minutes and 30 seconds would be okay to write, or 7.5 minutes would be okay to write. Okay? Because that would be 60 plus 60 plus 60 plus 60 plus 60 plus 60. Let's see. 1, 2, 3, 4, 5, 6, 7. That's 420 plus 30 more. There's my 450. So that's 7.5 minutes. Okay? Johanna used tiles to build a rectangular array with an area of 54. List all the possible dimensions. Dimensions is length times width, and it equals 54. is we're basically writing the factors of 54. And I know I can do 1 times 54. 54 is an even number, so I know 2 will work. 2 times 25, 26, 27. 2 times 27 is 54. 3 will work. Let's see, 3 times 20 is 60, so that's too much. 3 times 19? No. 20, no, 18. 3 times 18 will work. 3 times 18 will work. That's 54. Does 4 work? 4 doesn't work. 5 doesn't work. Does 6 work? Yeah, 6 times 9, right? 7 doesn't work. 7 times 7 is 49. 7 times 8 is 56. So 8 doesn't work. Does 9 work? Yeah, 9 works, and it's already up there. That's when you know you've gotten them all. So you could have a rectangle that was 1 by 54, super long and skinny, 2 by 27, 3 by 18, or 6 by 9. And those would all give you an area of 54. And this is a blast from the past. But remember that if it only had 2 factors, it would be a prime number. Remember? Prime number, 1, 2, prima donna. But 54 is not a prime number. It has way more than 2 factors. I see 1, 2, 3, 4, 5, 6, 7, 8 factors. So 54 is not a prime number. 54 is what kind of number? A composite number, yeah. All right, on to the back. What is blah, 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 rounded to the nearest 10? So let's look at this number. And if we round it to the nearest 10, we need to look at the digit that comes after, and it's a 6. So that 6 is either going to tell us to keep the 5 a 5, or bump the 5 up. What does a 6 tell us to do? A 6 tells us to? So I'm going to bump that 5 in the tens place up to 6. So 3, 2, 9, 4, 6, 0. The next one asks us to round to the nearest 100, and we have to look at the digit that comes after. So we're either going to keep the 4 a 4, or bump the 4 up. And what comes after the 4 is a 5, even though 5 is technically right smack in the middle. A 5 tells us to? Bump it up. So I'm going to bump that 4 up to a 5. So 3, 2, 9, 5, 0, 0. And the last one, rounding to the nearest 1,000. Look at the number that comes after, and it's a 4. So that 4 is either going to tell us to keep the 9 a 9, or bump the 9 up to a 10, which would then bump the 2 up to a 3. It's a 4. A 4 tells us to keep. Good, so we're going to keep that 9 a 9. 3, 2, 9, 0, 0, 0. Number 6, fill in the bubble to show which number listed below is closer to 445,890. I can really just look here. Is 445 closer to 440 or 450? Well, 445 is right smack in the middle, but the fact that I can see this number and that mathematicians decided hundreds of years ago to always round up, I can tell that I need to round up to the next number, okay? So we're really rounding to the nearest 10,000, and that 5 is telling us to bump it up, so 450,000. And remember, you can always think of a number line and think, here's 440,000, and this is just for you to see, and here is 450,000. So right smack in the middle would be 445,000. But the number they gave us was 445,890, which would be like right there. And you can tell that it's closer to that higher number. Number 7, if you wanted to round blah, blah, blah to the nearest 10,000, which number below would you choose? So let's round to the nearest 10,000. And I can see that what comes after it is a 3. A 3 tells us to keep. So I'm going to keep that 7 a 7 and make everything else a 0. Okay, last one. The challenge problem, Linda plans to sign up for 3 field day events. She wants to run a total of more than a kilometer, but less than 1.5 kilometers. Which 3 events should she sign up for? So that means she needs to sign up for something more than a kilometer. That means more than 1,000 meters, but less, let's see, 1.5 kilometers would be less than 1,500 meters. So I need to choose 3 things that when I add them together, they are more than 1,000, but less than 500. If it's got to be less than 500, you better know right away which event you can't choose. You cannot choose 1,600 meters. That's 4 times around the track. You cannot choose that because that's already more than what it's supposed to be. And she needs to choose 3 events. So you need to choose 3 events that will be more than 1,000, but less than 1,500. And there are a lot of possibilities, and it doesn't all have to be in like the same category. It can be any 3 events. Let's do an example. 800 plus 200 plus 100. 800 meters, that's 2 times around the track. Plus 200 meters, that is halfway around the track. Plus 100 meters, that's like just the straight part of a track. And if we add all of that together, that's 1,100 meters. Does that fit our criteria? Is 1,100 more than 1,000? Yeah. Is it less than 1,500? Yeah. So that would be a possibility for Linda to do. There's a bunch of other ones. There's like 5 or 6 other ones too. As long as it's more than 1,000 but less than 1,500, you're good. So circling these 3, that's a great choice because it's more than 1,000 and less than 1,500. All right, kiddos, here are the answers to the first page, 83, and the answers to 84. All right, kiddos, I will see you in class.